Hello, and welcome to Clayton Fire Department's Confined Space Rescue Refresher presentation. My name is Jason Dean, the Deputy Chief of Operations at Clayton Fire Department, and also a Level 3 TR Confined Space Rescue Instructor. This presentation is going to be used in conjunction with our awareness level training requirement, and can also be used for just general company level training if you're looking for a refresher topic to go over. This process is going to be slightly different than the past, whereas we have done a PowerPoint presentation or a Adobe presentation overview and test completion. With this process, we're going to do a video overlay for more interactive to discuss the various objectives for confined space response for Clayton Fire Department. These objectives are going to cover the Clayton Fire Department overview, the OSHA North Carolina Department of Labor overview, and a confined space operations overview. The course completion of this is very similar to what we've done in the past. You'll also review this presentation and then go on to Fire Manager in the Forms tab and open the Confined Space Rescue Refresher Test. If you are one of the personnel that need awareness level credit, you have also received a message indicating this need, and the test is required for verification of the presentation review. If you're doing this presentation just as a general company level training, you're welcome to do the test, but it's not necessarily required. But again, if you're one of those that received the message that didn't attend one of the other sessions this year, the test is required. If you received the message and you did attend one of the sessions, just give me a call and I'll see what the mix-up was there. For the training entry into Firehouse, the on-duty shift personnel can handle that. It's simply done by entering it as any other training entry. The difference is where to find the title. And most of the training entries done is using the in-house training topic. For this, they'll just simply scroll down in the description listing, and at the bottom of that listing is a rescue training for Town of Clayton. Simply open that description up, and then you will see the CFD Confined Space Awareness title that can be chosen for this entry. Everything else is like any other training entry, just enter the time completed, the personnel, and note in the rating criteria, technical rescue hours, Con Ed, and submit it as normal. As a disclaimer, this presentation covers awareness level only. We will discuss some operational overviews. However, the discussion is just that, a discussion. And overall, to do the hands-on or to be considered an entrant or operations level, hands-on practical session is required to meet those objectives. So let's talk about our capabilities, our background. We are a confined space provider at the technician level. We began training back in 1998 with CCC Fire Rescue, Connie Beasley. Then after a couple years of training with him, we decided to purchase the equipment, and in 2001-2002 time period, we become self-sufficient with equipment and training and instructors, etc. The need for this happened again in the late 90s. The Town of Clayton come to the fire department and requested us to provide confined space response, because at the time they were contracted with an outside agency for that, and there were some questions or concerns on that process, and also on the monetary side, the budgetary side, they could save money by allowing the fire department to do that service. At the time, with the staffing we had back then, we actually allowed, I shouldn't say allowed, we actually had personnel from Public Works, Police Department, Electric Department that also assisted us in a confined space response or the staffing for the personnel needs. Since then, we still utilize the Public Works and Electric Department as a resource, but not in the staffing process or the actual personnel needs in the rescue side. We also use a permit system and a worksheet we'll go over in detail, and personnel training levels. This can be confusing at times, whereas you've got North Carolina All-State Fire Marshal has a certification, then you've also got the NFPA 1006 and 1670 standards that specify certain objectives, that also say the authority having jurisdiction can specify things. But for the state certification, North Carolina does have a confined space technician certification. Along with that, we choose to use an entrant program or entrant level that personnel go through, and it pretty much mirrors the confined space technician objectives. Then we have our operations and our rigging, and per NFPA 1670, there are certain spaces that can be entered at the operations level, specifically spaces that can be easily entered and exited, allows a room for 2 or more rescuers, hazards eliminated, etc. But generally speaking, at the operations level, this is going to be restricted to personnel. Well, I shouldn't say restricted. It's going to be personnel that concentrate on the rigging and the setup. And the awareness level is just to make people aware of what a confined space is, aware of what the operational concepts are, and hands-on wise, they can potentially assist in some of the rigging or the equipment running or whatnot, but they're not going to be expected to be go-to personnel to set up things or make entries. As a Clayton Fire requirement, we require all personnel to maintain at least an awareness level of training for confined spaces. We are equipped with the North Carolina Association of Rescue and EMS as a confined space provider. And with that being said, if you're doing apparatus checkoffs, specifically the rescue truck, and you see certain equipment missing that is marked with an asterisk, bolded or otherwise noted, definitely let somebody know, because it's marked for any equipment is needed and needs to be passed on that is missing. But if it's marked with an asterisk or specifically noted, it's on there for a requirement, whether it's a DOI requirement or one of our specialty requirements. We also utilize a process from agencies, a notification process that they're making entries. The town of Clayton, Griffles, Hospira are a few of those examples. Anytime they're making an entry into a confined space, we are notified via email and sometimes phone, depending on the time frame that these entries are being made. Very rarely do we have to do a physical standby at these spaces, whereas these entries are often done in environments that are controlled or hazards have been eliminated. Very rarely, again, are they doing entries in hazardous environments, and very rarely do we have to do physical standbys. On an annual basis, we receive anywhere between 100 and 120 notifications from confined space entries. A lot of these come from Griffles, especially during their shutdown process. When we receive these notifications, oftentimes we'll forward them out to the on-duty personnel working, or just give a heads up, hey, they're doing confined space entries, on the river trail manhole system. And on the other side of that, if they notify us that they're doing a confined space entry, and we have certain issues, there's been a couple times where like when we're doing training, we're doing, they may send us a notification, we'll send them back, hey, we're training that weekend or we're training that day, so our response may be delayed. And on the other side of that as well, when we do training, we also notify these entities that we're doing the training, so they have the opportunity to come out and evaluate us on our skill proficiency, which is an OSHA requirement. Well, it's an OSHA option. The 1910-146 standard has it specified that it's a non-mandatory option for employers to evaluate their rescue services. So there's just another option out there. Alright, so that wraps up the Clayton Fire Department's overview, the response overview. Now we're going to go over the several OSHA updates on North Carolina Department of Labor. As an introduction, North Carolina Department of Labor, or North Carolina OSHA as they refer to themselves sometimes, is the regulating agency that has standards set aside, and being an OSHA state, as North Carolina is, they have the option of creating workplace safety standards, and most of them mirror the federal standards. The aspect of being an OSHA state is you have to meet or exceed federal regulations. And with that being said, North Carolina Department of Labor does that. They have a website, nclabor.com. You can go to the compliance standards and see various training materials that are available there. Some of them are free, some of them you have to purchase, download. But keep in mind that that site and the Department of Labor is more focused on general industry and construction companies and things like that. However, fire rescue agencies that respond to confined spaces also have to comply with safety procedures and mandated standards. So here's the actual confined space, permit required confined space standard, OSHA standard 1910.146. Its overall purpose is to prevent occupational injuries and illnesses and deaths associated with employees entering and working in confined spaces. This standard actually was enacted in 1994, so it's only a 20-year-old standard, 21 years old. With that being said, there were several deaths prior to that. Obviously, confined spaces were entered prior to 1994. The multiple deaths associated with confined spaces caused the need of setting forth a standard, and hence the 1910-146 standard was created. Part of the confined space standard requires employers to develop a program or have a program in place that is mapped out by the standard, and with this program they have to control and where appropriate protect employees that work in or around confined space areas. There are other applicable standards that are related to confined spaces, and we'll talk about some of these in detail throughout the presentation. The 147, the lockout tagout, we actually have our own policy that utilizes that standard. Your 1910-134, respiratory protection. This is where your self-contained breathing apparatus, your SCBA, your supplied airline respirators, your fit testing, all that comes into play. And then your 120 standard, your hazardous waste or your hazmat standard. Oftentimes these confined spaces are storage vessels or transport areas for specific products, so you have to follow the 120 standard for some of those aspects. So what is a confined space? In my direct delivery classes, I will actually take a minute or so and get some feedback. So if you want to pause the video here, and especially if you're with a group, and kind of discuss amongst yourself, if you had to define a confined space in your own words, what would it be? The OSHA standard provides this generic description here. Your tanks, your vessels, silos that are 4 feet deep or greater. That 4-foot rule comes into play when we get into the hazardous atmospheres and your vapor density concerns. But for a space to be a confined space, it has to meet 3 criteria. One is the space has to be big enough and configured in that a person can physically enter the space and perform work. Second, the entrance and or exit has restricted or limited means for entry and exit, so it's hard to get in and out of the space. And third, it is not designed for continuous human occupancy. And if you took the little bit of time to get your own definitions, a lot of times people will say, oh, it's a tight area, tight space, it's confined. And while that is true, you could actually have a space such as The example I use often is a ship vessel. You could have a ship vessel or a vault that could be the size of our apparatus bay, but to get in and out of that vessel, you have to go via an 18-inch manhole portal type opening that would be classified as a confined space because of the restricted or the limited means for entry and exit. But it's big enough to enter and do work, and also it's not designed for continuous human occupancy. Various examples of confined spaces. Here's your general common one everybody refers to, your manhole. This could be a sewer system, a waterway system, but you also see the signage there, confined space entry permit required. And part of the 146 standard, there's some verbiage in there that requires signage to be posted at confined spaces. And it could also cause some questions when it comes to manholes on the streets. And I've been asked, well, if the standard says that, how come Clayton don't have all their manholes labeled? Well, first of all, it's impractical to put road signs up in the middle of the roads. However, to meet the intent of the standard, one thing they have done recently over the last couple years is the manhole covers that are new will likely have the verbiage stamped on it, danger, confined space. As a reference point, if any of you are ever in the area of the police department, the law enforcement center, if you go in their side parking lot, there's a manhole or a vault to the right. If you turn off of Horn Street into the parking lot, if you look to the right, you'll see like a concrete vault with a manhole cover. That's a good example there. That's one of the newer ones that has that danger, confined space verbiage stamped on it. But for the other areas that don't have that stamped on there, the standard also states in the confined space program you have to limit access and egress if employees are expected to work in them, or in that case, a manhole is out in the general open. It does have a very big limitation on getting in, because you're not just going to walk by one of these manholes, bend over, and just flip it off. It takes a considerable amount of effort to get these manhole covers off. Your water towers, these are confined spaces as well. Inside the water tank itself, maintenance has to be done. As a matter of fact, during the development of this presentation, the elevated water storage tanks in Clayton are undergoing their annual maintenance and sampling and testing, where over the next few weeks people will be working in our elevated storage tanks where there's a higher potential of an incident. The problem with these is you could have the person down inside this water bowl, so there you've got a confined space, but when you get them out, you also have to get them to the ground. And as the notorious water tower picture dictates, Indianapolis had last week. Indianapolis Fire Department had an incident with this exact scenario where a worker fell 30-40 feet inside the water bowl. They had to go up, get them out of the water bowl, and then lower them to the ground. Most of confined spaces, and if I had to say a percentage, I'd say 90% of confined space rescue is rope rescue. You got that small 10% that is specific to confined spaces, your specialty PPE, your communication systems, your airlines, your air monitoring. You've got a small percentage of that incident that is tied to the specific hazards of confined space type work. Just another example here, you see signage, water treatment plant. These vaults are typically 4 feet or greater. It's just another example. Typically we don't tie ourselves to a rope during water rescues, but this is actually a confined space rescue. So there are exceptions to the rule, but here's just an example that you could contend with at a treatment facility. So you've got a space that's a confined space. Now if that confined space meets any of these criteria, it's considered a permit required confined space. And this is probably one of the more confusing aspects in the standard, because if you ask a compliance officer, they're very quick to tell you that any confined space is a permit required confined space until deemed otherwise. And hence even the standard name, permit required confined space is the standard name for the 1910-146 standard. So any one of these four contains or has the potential to contain a hazardous atmosphere, the potential to engulf an entrant, internal configuration that could trap or asphyxiate a person, or the catch-all that contains any serious or safety health hazard. There's also in the standard mentioned a non-permitted or a non-permit required confined space, and this is allowable in the general industry where an agency or an industrial facility, we use the example of Caterpillar. If they have their confined spaces, they have them, they're permitted, they go in, they do their permit, or they draw their permit up, they go through their hazards, they eliminate their hazards. Per the standard, they can technically declassify or reclassify it to a non-permitted confined space. So that is an option. The reason I'm mentioning it in this presentation is because at times during a response, as we roll up, it's happened in the past where emergency response gets there and they're very quick to say, hey, look, here's my permit. It's actually been reclassified to a non-permit. Everything's okay. Just get in the space and get my guy out before Department of Labor gets here. And that's fine. We'll take their permit. We'll review it. However, we still have to follow the permitting systems. The reason for that, and we're not trying to be hard to get along with, but this is an excerpt from the Confined Space Standard. It's an algorithm or a step-by-step process to guide employers on working with permit required confined spaces. It starts off, does the workplace contain a permit required confined space? Yes, it does. Will it be entered? If it doesn't contain a confined space, you're going to consult other OSHA standards. And as you see here, it goes down. They ask a question, is it yes or no? It takes you to another section. It talks about your entering, talks about the potential hazards, and you see near the top there, can hazards be eliminated? If they can technically reclassify the space as a non-permit required confined space. If they cannot, can the space be maintained by using continuous forced air only? No, they prepare for entry using permit procedures. So it gets down to the permit. Verify acceptable entry conditions and then issue the permit. So things are going on and something bad happens. An emergency exists. Entrants are pulled out, the entries are boarded, they call rescuers if needed, and then there is the magical word, the permit is void. So that permit that entity may have showed you, it is no longer valid. And the reason for that is because we are there for a reason. And it could be debated. The person could say, well, we eliminated our hazards, so we didn't even, it was reclassified as a non-permit required confined space, so we didn't issue a permit, so therefore just go on in there and get my guy out. And that's one of those things that it can be very easy to say, oh, that makes sense. However, again, we're there for a reason. Maybe they didn't eliminate the hazards, or maybe a hazard appeared post their initial evaluation, or maybe what they're doing is causing a hazard, as far as their ventilation processes, or maybe they didn't lock out and tag out something correctly. So it's always safest bet to use the permitting process. It is a step-by-step process. It can be lengthy or can add time to it. And people say in the rescue mode you want to be quick, and that's fine. We do, but if you rush through some of these safety concepts, worst case scenario can happen, and now you're spending more time doing a recovery versus a rescue. So there's your step by step. It talks about auditing the program. With the permits, we have to maintain permits for at least a year. Our permits are maintained more than that. Our retention schedule, I think, is set at 5 years. However, we've got permits that date back to the early 2000s if you look in our confined space file. Okay, so that pretty much covers the basic OSHA overview, the processes and definitions that they look at. There are a few things that OSHA refers to that is different than fire rescue. One of those is some of the definitions, and we'll go over those as we talk about the permitting process. But now we're going to kind of dive into the operational concepts, and confined space rescues fit the category of a high risk, low frequency type event because they don't happen often, but when they do, there is a lot of risk to it. With that being said, this acronym you see here is used for various technical rescue classes or incidents, and the failure to understand or underestimate the environment, additional medical implications not considered, your inadequate rescue skills, lack of experience or teamwork, the underestimating the logistical needs, rescue recovery modes, and your equipment. All of these, if one of these fail, it's likely that your incident will fail. And we're going to talk about each one of these as we go through the operations. So, operations of an incident. There's 4 levels or 4 sections of operations, and they consist of phase 1 is your assessment phase or your primary assessment. Phase 2 is your pre-rescue. Phase 3 is your rescue, and phase 4 is your termination. So let's look at each one of these levels here. Your preparation assessment, this is talking about the evaluating of a rescue team, equipment, and rescue personnel. And actually this would actually start prior to even an incident. I'll use Clayton for an example. We evaluated ourselves back in the late 90s when we had the request from the town to do this. So even dating back to then, we evaluated our personnel, our equipment needs, the team concept, and kind of fast forward to now and even to an incident. When you're on that incident, you have to assess your team for that particular type of incident, assess your equipment, assess your rescue personnel. What kind of incident are you dealing with? With this, the advantage of a confined space incident is we have entry permits. For one, they're required by OSHA. 2, it serves as a great guide or a great process making or information gathering tool. Decision making takes place here, scene control, which is also identified in the permitting system. So here you see this list of several aspects needed for a permit. The permit attributes are defined in the OSHA standards, so these things you see here on any confined space permit, these things have to be addressed. And here's some of the verbiage I was mentioning earlier about the OSHA terminology. Entry supervisor, this is an OSHA terminology where the person that is in charge of that entry. In our world, incident commander would be that. So some of the things, if you look at an OSHA permit, it may not jive with our jargon. So what we've pretty much done is we've taken our permit or the permit requirements and put to our own confined space entry permit. I know it's probably a little hard to read on the screen you're using, so if you want to take a few minutes, pause the video and go get a permit. They're available on the apparatus in the apparatus clipboard. You can also print them off from the R drive and our SOG file. So if you want to take a couple minutes and pause the session and get a hard copy to kind of go by, we'll kind of look at each of these sections to dissect the permit process. So at the top, you've got the incident commander, self-explanatory, the date self-explanatory, safety officer, barrier tape, that's one of our first signs of scene control that's required in the assessment phase. Job supervisor name, this is, let's say we go to Caterpillar and Frank Doe is in charge of this confined space entry process going on. That's whose name goes there. This is typically not going to be a fire rescue personnel name. This is going to be who we're responding to. The location of the incident, self-explanatory. The type of work being done. Again, this is what was that facility doing. That Caterpillar confined space entry. What were they doing? Were they changing out a valve? Were they cleaning the inside of a vessel? Now, the nature of the problem, you see going on down to the nature, this is where we come in. What's the nature of a person? Person's unresponsive, missing person in the space. This is where we write the problem down. Then you've got your known hazards and the control measures used, and getting down to your atmospheric monitoring. This is to be done as soon as possible, and continuous monitoring is required. One of the requirements with the permit is that you have to show the acceptable entry levels, because most people will not remember what the oxygen range is, what the LEL percentage, 10% of lower explosive limits, the 35 parts per million for carbon monoxide or 10 for hydrogen sulfide. Most people are not going to remember those levels, so the permit has it on there for referencing, and it's here on the right, about middle of the page, for that reference. So here's what we're looking for, here's what we write down, and what we find. The good news is on our air monitors, if you're outside of these ranges, our air monitors will go into alarm. The type of monitors we use are all Scots, and here if you want to write beside it, Protege, that's fine, but you don't have to. Last calibration date you'd get from the air monitor log, and we're also going to bump test it as it's required for any time we use our monitors. Your safety brief and IAP is required for all personnel on the scene. We'll go over more details when we get into the pre-rescue phase 2. Then you see the rescue methods control list. So all this stuff's going on, and some would say, gosh, this is a lot of information going on. This might as well be a confined space recovery permit. Well, you got to remember, as this incident commander or the recorder is doing this, you've got various other tasks being done. You've got the rigging group rigging up the tripod. You've got your rescue group putting their harnesses on. You've got atmospheric monitoring, ventilation group doing their thing. You've got a lot of things going on, which it kind of goes back to that failure acronym with the teamwork. You've got to train at these things. A lot of things are happening while this permit's getting completed. So the incident commander is going through, checking this stuff off, looking up, seeing the rescuers. Okay, they're wearing class 3 body harnesses. Okay, we're using a communication system. They get down to the bottom and sign it off. This signature is required prior to entries being made. This is that checklist of verification that everything's in place. They'll time and date it, and that will be the front page of our permit. The atmospheric monitoring page, self-explanatory. This will be separated from the permit process and given to the person monitoring the atmosphere, the ventilation group. Sometimes this is given to the accountability person just for the logging aspect. It just depends on what personnel you have on site and who's able to do this information. Typically for atmospheric monitoring, we want to do every 5 minutes or so for that continuous monitoring. Personnel assignment, this will obviously go to the accountability person. Self-explanatory, you got your rescue team, what team number are they, if they're using airlines, what color are they on. Our airlines have the colored tape throughout the airlines itself, if they're using supplied air, or if they're using SCBA, what their PSI is. Time enter the space, time out of the space is pretty important as well, especially if we're using air packs, because we do have a limitation on our air packs. If you kind of go back here real quick to that front page, if you notice down here under respirators, it says here supplied airline respirator or SCBA. If we're using SCBA, we are limited to 1/3 the time average for the safety of the personnel. Meaning, if we're using a 30-minute bottle, we're limited to 10 minutes of inside time on SCBA. Now, if we're using supplied airline, that's a different story. So here's where you just write that PSI for the SCBA, and then also time in, time out, so that way we can monitor how long they've been in the space. Sometimes the first person in may need to be the first person out if they're using the SCBA. Your attendants and your riggers, their names will go here. You can check one or both. Were they an attendant or were they a rigger? Your attendant in the OSHA world, in the OSHA verbiage, that's the person that's standing by that space, monitoring the entrance inside the space. Oftentimes, our attendant, if we're using the hardline communications, the attendant will also be wearing the headset to hear the entrance and to be able to converse with the entrance. The rigging personnel, the ones doing the rigging, They can also obviously assist with keeping an eye on the personnel inside the space, but they can do one or both. At the bottom, you've got your IC and your recorder, your radio channel, etc. Medical vitals, self-explanatory. We'll give that page to EMS. They do have the option of using their own rehab form. If they do that, we just need to get a copy of that and put with our permit. General notes section, nothing special about this other than just a page that's set aside for general notes, and then the debriefing page or the critique page. Whether it's a training evolution or an incident, we can use this to make different notes about what we learned, what went good, what didn't go so good, etc. So all this stuff is kept as a package per se, as the permit. So it starts off as a package. It can be separated into individual groups, and then at the end of the day, everything comes back together, is put back and filed away. The worksheet, this is not necessarily a requirement per OSHA. It's just a guide that we can use as a check sheet. If you look at the worksheet, it kind of mirrors the operations plan, the different levels of operation. You got your response, your primary assessment, a couple reminders in there, your safety briefings required, and you can go on to your logistics. We talked about the failure acronym earlier, understanding or underestimating the logistics of a confined space incident, and you see the various needed positions or potential positions you may need at a confined space. Can some of these be doubled up? Sure, just depends on what your staffing is. Air supply person, your atmospheric monitoring person may be the same depending on what all you have going on. Rescue operations, again, you see the step-by-steps. It don't necessarily tell you how to do things, but it tells you to do things. And as with the permit, this is also available in our apparatus clipboards and in our SOG/SOP file. So if you're going through this presentation and really thinking, hey, I'd like to put my hands on that, by all means, feel free to pause the video and go get one of those to go buy a hard copy. Termination phase, again, account for all personnel, secure all paperwork. You can read the checklist there. Again, it don't tell you how to do it, just tells you to do it. It's just a good reminder. Somebody that has done confined space work in the past, all these things should be pretty familiar, but again, this is just one of those check and balances that we can do to make sure we don't miss anything or just to verify certain things. So the operations of incidents still in phase one. Kind of just to reiterate some of these, are on-scene resources sufficient? Mutual aid, yes, we can use mutual aid for responses. We may use mutual aid to backfill our fire station for fire calls, or we may use them to assist us on the scene. They can be equipment runners or whatnot. We just have to control where they go and where they're at. Establish scene control, that could be as easy as shutting a door. At Caterpillar, some of their confined spaces are inside of a room. We could shut the door and there you go. You've got a scene control that can keep unnecessary people out of the area. Control zones, hot zones, warm zones, cold zones. The easiest thing to do with that, to maintain control, is to have access areas where to get from the warm zone to the hot zone, it's a physical barrier, tape or fencing that's put up, and at that entranceway put your accountability person. So as that person goes into that hot zone, we can confirm they've been safety briefing. They've had the incident action plan. They're aware of what's going on. And probably one of the more serious things to consider are the immediate hazardous areas. Dealing with confined spaces, the atmospheric issues are our number one problem. And it's very likely, if you've got a space that has one opening, you put good air in that opening, and bad air only has one way to come out. So just remember your attendant or your rigging personnel, they may be on that. They may need air respiratory protection. In addition to them, to those personnel, if you've got others, bystanders or other people in the area, we don't want to affect them by that bad air. So we just need to assess that situation. Just another list of hazards of confined spaces. Again, number one is atmospheric hazards, then your physical hazards, environmental and psychological. There are certain people that will not or don't like to go or will not go in certain spaces, either mentally or even physically. And that's okay, because most of the time there's more to do outside that space than there is inside the space. The leading cause of death is oxygen deficiency, hydrogen sulfide, methane, inert gases, or just to abbreviate it, is atmospheric hazards. Atmospheric hazards is the leading causes of deaths in confined spaces, followed by engulfment and then mechanical asphyxiation. Okay, reasons for people dying in confined spaces. The leading cause of death is atmospheric hazards, as I just mentioned, but the reason people die is a little bit different. Compassion accounts for approximately 60% of deaths in confined spaces, or also known as would-be rescuers. Don't get confused with the term rescuers as fire rescue EMS personnel, but these are typically the co-workers of the people that are working in these confined space environment. Now, some of them are rescuers from some of the case studies, but for the most part, most of these rescuers are the co-workers of people. A real quick case study in the western part of the United States, in a city, a public works crew was working in a sewer. Person collapses in a space. Co-worker looks in the space, sees him, climbs down into the space to help him out. He collapses. Supervisor comes by the site, doesn't see his personnel outside the space, but sees their vehicle. He gets up to the space's opening, looks down, sees the two people. He climbs down into the space to render care. He collapses. Police officer's doing a patrol. He comes up to the area, sees these couple of vehicles, doesn't see anybody around it. He gets out to investigate, gets to the opening, looks down, sees these three people at the bottom of the space. He climbs down into the area. He is overcome by the hazards. Somewhere in this time period, it's not quite clear in the case study, but 911 is contacted. I believe it's by a passerby that's walking on the sidewalk or whatnot. But fire department responds. They get there. The first in company officer gets off the apparatus, goes to the space opening, does his size up, sees these four people in the space, goes to climb in the space, but due to the fact that the space is so full of dead people, he can't get all the way down to them, which is a good thing, because if he had, obviously, he would have succumbed as well. He did have some slight exposure to the gases in the space, but he didn't die, which is obviously a good thing. But it just goes to show you that compassion side, or the would-be rescuers. And sometimes it's like in the case of the firefighter or that company officer, it may be in a simple case where he didn't know what he didn't know. He wasn't aware of confined space hazards. So compassion, again, 60% of deaths. Complacency, we see this often in areas where people work often in confined spaces, and they have the mindset of, I've been doing this X amount of years, it's never happened to me, it's not going to happen. The complacency process. Children, the good news is we don't deal with children cases often in confined spaces. Again, most of confined space responses are to workplace environments. The most notorious or well-known children case would probably be baby Jessica in the well back in the 80s, when baby Jessica fell in the well and they had to do the rescue for her, ultimately digging a shaft beside the well she fell in and tunneling over and getting her out that way. The other issue or reason people die is they fail to realize most hazardous atmospheres are invisible. They just say, well, I can't see anything bad, so there's nothing bad in there. Or they think they can affect the rescue before becoming overcome by the hazard. There's another case study in the book that refers to a person trying to rescue a family that had that compassion. They were down in a manure pit in one of the barns, and a person tried to effect the rescue by holding their breath, going down into this manure pit. If they fail to realize back to the hazardous environment being invisible, So they trust their senses. You see as the other bullet there, they don't smell anything, they don't see anything, so they trust their senses and go into the space. So all of these are reasons. The last reason you see there, not following the OSHA standard, that standard was put in place for a reason. It has very specific step-by-step processes to follow, and we've got to look at it from the concepts of, if they followed the OSHA standard, we wouldn't be there. There wouldn't be any emergency. Now, there are cases of accidents do happen. Baby Jessica in the well, that was an accident. In her backyard, an abandoned well covered by a rock. The rock was moved, and the baby fell in, and Baby Jessica fell in the well. So things do happen, but for the most part, statistically, the accidents that happen in confined spaces are at workplace environments. So we've mentioned hazardous atmosphere. Here's the official definition of hazardous atmosphere. An atmosphere that may expose employees to the risk of death, incapacitation, impairment of ability to self-rescue, injury, or acute illness from one or more of the following causes. So any one of these 5 causes makes an atmosphere hazardous. So let's kind of talk about each one real quick. Oxygen concentration. In the room you're sitting in right now, the oxygen concentration is probably around 20.9%. Anything below 19.5 is considered oxygen deficient. Anything over 23.5 is considered oxygen enriched. So therefore, the 19.5, 23.5, that is the acceptable entry level without any respiratory protection. Obviously, anything below 19.5 or oxygen deficient is bad, because we need oxygen to survive. And at 2 to 3% oxygen concentration, that person's going to go unresponsive in a matter of seconds and be likely a fatal exposure. Where around 12-14%, it's not necessarily a lethal level, but what it does to the body is pretty bad. It increases respirations, it causes fatigue, and it also causes poor judgment. So these simple processes of how to open or close a valve, those processes are altered at that level. Anything over 23.5% oxygen enriched is bad for flammability purposes. The good news about oxygen enriched atmospheres is all of these cases are mechanically induced. Confined spaces don't naturally produce oxygen. So if we have an oxygen enriched atmosphere, we need to find the source, and hopefully we can isolate the source. An example, person doing a hot work permit in a confined space, so they're using an oxygen saline cutting torch. They go on lunch break, they cut their saline off, they think they cut their oxygen off, they go on lunch, they come back in an hour, get inside their space, so their oxygen bottle has run out into the space, they get their striker, go to ignite their torch again, and a possibility of an explosion. So that's an example of a mechanically induced oxygen enriched atmosphere. Flammable gas vapor mist exceeds 10% LEL. LEL is lower explosive limit. That is at a point where something may explode but not sustain combustion. The good news about this is LEL, lower explosive limit, at 10%, it gives us a window of time to make changes. Obviously, you could get into an environment and you're already at LEL. Example being, let's say you have a product X, its LEL is 100. You get into the space and all of a sudden your alarm, your meter is going off and it says 100 on it. On the LEL sensor, obviously you're in an explosive atmosphere. Hopefully we don't get into that kind of atmosphere. Hopefully if we're in an environment, it's going to go off pre that level, before it gets to the lower explosive limit. So at 10%, our monitors are designed to go off at 10% of LEL. And the product that is used to calibrate our monitors is methane. That is the most common gas in confined space or in hazardous atmospheres, is methane. And if you think about it, methane is also used as the biggest product or the biggest nomenclature of like natural gas. And the good thing about methane, its calibration process is equal to 1 as far as when we're looking at setting up ranges and percentage. And that's why a lot of your air monitors use either methane or some kind of pentane to do the calibration with. So kind of get back on track with the 10% side. Let's say product X, that same product X has a LEL of 100. So at 10, your meter is going to go off an alarm. So it gives us that 90% window to make changes, whether we need to evacuate the space, figure out what's causing the sensor to go off, what's being introduced into the space to cause that. Combustible dust meets LFL, lower flammable limit, and as the lower flammable limit is at the point which will support combustion. A general rule of knowing if you're in a combustible dust environment is if it obscures your vision more than 5 feet, you can consider that as a flammable atmosphere and dust. Now keep in mind that's a general rule. An example being, we have our automatic roll facility here in Clayton that makes your buns and stuff, or for McDonald's. They obviously have a bulk supply of flour and other fine material used to make that bread. You could have, the finer the material is, the more of an issue you could have. Example, fire behavior classes, I use a dust explosion chamber to illustrate that dust can be flammable. This T-picture is the explosion chamber I have is just a simple T-picture with a candle in it, a tube to a funnel. I put some cornstarch in the funnel, light the candle or hold a lighter into the T-picture area. I blow a puff of air in the tube. It disperses that cornstarch to a fine dust, and a fireball comes out the top of the T-picture. So just an example there. It don't have to obscure your vision of 5 feet to potentially be flammable, and that's probably going to meet more of its LEL, explosive, because even though it don't explode, it ignites and it doesn't sit there and burn continuously. But again, just another example of how that can be illustrated. Toxicity, known materials in their PEL, and IDLH, or immediate dangerous to life and health condition. Flammable atmospheres, just an illustration here, you can have too rich or too lean to burn. The problem we have with this is ventilation concepts. If we have an atmosphere that's too rich, we have to do ventilation to get rid of that toxicity process. However, by doing the ventilation, we are likely to bring that atmosphere into its flammable range. So we just have to be cautious on the products we're using for lighting, communication, etc. Just sources of ignition. But as you can also see, as hotter the fire gets, so as higher the temperature gets, that flammable region expands. I mentioned during the hazardous atmosphere, the 5 definitions. I kind of breezed through the PEL and IDLH, or immediate danger to life and health, because we're going to see it again here. PEL is the maximum level of toxic substance that an individual may be safely exposed to, and then you have your time-weighted average. Your time-weighted average is actually the amount of time that a person can safely be exposed to 8 hours a day, 40 hours a week, and these can be used interchangeably. And from the PEL or the TWA, you may also have a short-term limit value, which is a little bit higher. So let's say carbon monoxide, its PEL is 35 parts per million. A short-term limit value may be 50 parts per million. Its IDLH, or immediate danger to life and health, may be 100 parts per million. So as that part per million goes up, you can see a change in your exposure limitations. And your vapor density of gases. Vapor density of gases is what gases weigh in comparison to air. This is pretty important for confined spaces because it's going to tell us where these gases are going to be at in relationship to the location in the space. Carbon monoxide, as you can see here, its vapor density is 0.9680, so it's less than 1, so it's lighter than air. Sometimes carbon monoxide is referred to as being the same weight as air, and that's okay. If you round it up, it is. But technically, it's slightly lighter, so it's going to kind of flow evenly throughout currents or HVAC systems or ventilation systems and whatnot. Hydrogen sulfide, or sulfur dioxide, on the other hand, is heavier than air. So it's going to be located near the bottom of a space. Now, don't get complacent. Say you've got a space, say this space is 40 feet deep. Say it's one of our lift stations here in our district. We pop the top, and immediately our hydrogen sulfide sensor goes into alarm. All that simply means that the space is full. Okay, don't get complacent on if it's heavier than air, staying at the bottom. Obviously, if it's heavier than air and it's registered at the top, it just simply means the space is full. The control of our physical hazards, there's various methods we have to do this: lockout, tagout, blind and bleed, blanking, and ventilation. The blind and bleed blanking processes typically will utilize outside resources or facility maintenance for these processes, because as you can see in the illustration, that's dealing with some concepts that we don't specifically carry with us. These blanks where we can take a open flange out, put in a closed section, a blank, and isolate it that way. And hopefully these processes are done prior to our response, and if they are done, hopefully a response won't be needed. But for the more common control aspects that we do, lockout, tagout, and ventilation. So let's talk about lockout, tagout. Okay, lockout, tagout. Again, this is another aspect that is regulated by the OSHA standard, and the OSHA standard again is 1910.147. Per OSHA and also NFPA standards, confined space rescue teams should have their own lockout tagout kits, and we do. Each engine has a small lockout, like a single lockout tagout kit. The trench trailer, collapsed trailer, has a small lockout tagout kit, and Rescue 1 has the larger 6-lock system. As this the top picture here is that particular lockout tagout kit. We also have our own lockout tagout policies in place. Ideally, the first in will get there. Even if the company has locked it out and tagged it out, we still have to put our locks on it as well. And a real quick breakdown of how that works is the first in company will put their lock on it. Our hasp, our lock, our tag, and if it's a first in engine, you can use yours. If it's Rescue 1, we prefer to use lock number 6. As you can see noted in the picture, each of the Rescue 1 locks are numbered, and on each lock is a key, and then there's a key ring in the lockout tagout kit that has keys to the individual locks itself. So first in gets there, will put their lockout tagout system in place. The safety officer will be assigned a lock for them, and each assigned team will be given a lock. The team leader will be given a lock. Example being Team 1 can be given lock 1. Safety officer will unlock lock 1, remove the key from the hasp area, give the key to the team leader. That team leader will then hold on to the lock. Whenever they enter the hot zone, they will apply their lock, as you see in the picture, to the hasp. They will do their work. Let's say Team 2 comes in, they'll have their lock, they'll put it on. If we fill up all the holes on the hasp, we can simply take another hasp or system and kind of put it in place with the existing. And the advantage of this is when Team 1 gets done with their assignment and comes out, Team 2 is still in the hot zone. They know the system is still locked out and tagged out. So that's the breakdown on how it works. Again, if you want to put your hands on this physically, the SOG SOP file has this, and there's also an excerpt from the policy that's in the lockout tagout kit. Secondary assessment. So everything we've talked about before was the primary assessment of phase 1. Now we're secondary assessment. We're going to talk about the hazard assessment, the scene size ups, the current and future resources that we need, and mode of operation, rescue versus recovery. We're going to show a video, 2-3 minute video. This video is actually live footage from the 1984 Phoenix Tolling storage tank explosion. This particular case study, it's considered a confined space case study, and is also listed in the case study book I mentioned before. But this particular incident killed one worker and also killed a firefighter and injured, I think, 36 others. And this is by no means an attack on Phoenix Fire Department. Again, 1984, this was 10 years prior to even a confined space standard being developed by OSHA, and it's probably one of the bigger ones that spiked a need for regulating these this type work. So the video is going to start, and as it starts, you'll notice it's an aerial footage at first from a helicopter. You'll notice a small batch of tanks, like a tank farm. On the right side of the tank farm, you'll notice a fireball come out of the top of this tank, and that is actually the explosion that occurred as the fire department was cutting into this tank vessel to remove the person that was inside. And at the time, they thought this was the best approach. And even in 1984, confined space rescue wasn't a hot topic per se. So take a couple minutes, watch the video, and we'll discuss some of them, how it ties to considering our mode of operation.
In the next case, an employee at a petroleum facility fell victim to toluene vapors within a 12 by 24 foot vertical storage tank. He entered through an 18-inch opening on the top and was to lower himself on a rope. Next, an SCBA was to be lowered to him. However, he never made it to the bottom under his own power, but rather fell victim to the vapors. The fire department was notified for rescue and EMS. Upon their arrival, the firefighters found the only access into the tank was through the 18-inch opening on the top. Upon inspection from this vantage point, the bottom of the tank was found to be obscured. Feeling this was a life-and-death situation, tunnel vision occurred, resulting in the decision to cut a hole in the side of the tank and remove the victim through the opening. The rescuers were under the false impression that water fog would help the situation by eliminating sparks on the inside and outside of the tank. However, this line of reasoning may have contributed to the disastrous results that followed. The fog line may have injected air into the vapor-rich mixture on the interior of the tank, lowering it into the flammable range. Also, the application of water to the area being cut does not reduce the sparks, as can readily be seen. As the third side of the hole was cut, an explosion occurred. Victims all suffered the effects of concussion caused by the blast. Because proper protective equipment was worn, most suffered only minor burns. Other firefighters now rushed to the aid of their fallen comrades. As the casualties were assessed, it became evident that one rescuer had been grievously wounded and was later to die. The autopsy of the original victim revealed his death had occurred a period of time prior to the explosion. The autopsy of the rescuer revealed a massive displacement of thoracic organs caused by the concussion of the explosion. A rescuer died in order to recover a body.
Alright, so as you heard there at the end of the video, it made the comment, a rescuer died to save a dead body. And all this ties back to the risk-benefit analysis. Ironically, Phoenix Fire Department created what is commonly used for the risk-benefit analysis, in stating that we respond in rescue mode. We respond in that hurried fashion to save a life. And overall, we will risk a lot to save a lot. We risk a little to save little. We risk nothing to save nothing. And dealing with confined space incidents, these are your high risk, low frequency type events. So we do have to kind of slow ourselves down a little bit and look at some of the hazards that we're dealing with. The heart, or the head versus heart mentality, as we mentioned before, compassion can get the rescuer killed. Again, 60% of people that die in confined spaces are would-be rescuers. Remember to act responsibly regarding rescue and civilian safety. We definitely want to save lives, but if it's at the cost, needlessly, of rescuers, that's not acceptable. So we understand accidents can happen at times. However, most accidents out there have always been pointed back to a reason or a process that could have prevented that accident. The three major things that will greatly enhance the potential for a successful operation are special people, equipment, and training. And if you kind of go back to the failure acronym we mentioned before, it talks about the failure of an incident if you don't realize the need of equipment, training, and those people. So you see how all this is tied in together back to the risk-benefit analysis. So that concludes phase one. Let's go into phase two. Here's where we actually start putting more of the operational aspects together. In phase one, it's a lot of the kind of the paperwork going on, gathering information, risk-benefit, a lot of the thought process, scene control. Now for phase two, the pre-entry operations, this is incident action plan is taking place, safety briefing is done. So as all that entry stuff is being prepared, permits being filled out, you've got a lot of things going on. Atmospheric monitoring is doing their thing, ventilation, preparing the space. So after all this is said and done, the operations section chief, typically from the information gathered, will have a game plan ready. So they'll bring those people in and say, okay, here's what we have. We have a person inside of this vessel. We're going to do a top entry via tripod system. Go in with a sked stretcher, etc. All this stuff is explained to everybody up front. The concept behind this also is that everybody understands their roles and responsibilities. You see here your typical ICS org chart, who reports to who. Again, you don't have to necessarily fill every single one of these blocks. This is the toolbox, as I like to refer to teaching ICS. But again, just a good idea on what could potentially be needed. Phase 3 is the rescue operations. And I'm going to back up real quick to the pre-rescue, as I mentioned before, with the IAP and the safety briefing. Just as a reminder, everybody has to have that IAP or that safety briefing. A common way to do that and control that is to set up your accountability at an entryway into the hot zone. Because when OSHA gets there, the North Carolina Department of Labor gets there, they're going to want to make sure everybody's had a safety briefing. So if you've got these resources that come in late, you have to build in a system to make sure they get that same safety briefing that everybody else did at that initial meeting. So that's all been done. We're into our rescue operations. Personnel accountability, obviously, we do this pretty well on other scenes, so there's no difference here. Entry decisions, are we going to make a vertical entry? Are we going to make a horizontal entry? How are we going to search the space? What's in the space? Are we going to do a traditional, building search where a rescuer goes in, stays on the wall or stays oriented to the wall or some other object as the other ones search? Or does the space limit that? Treatment stabilization, that's all going to be dependent on your atmospheric hazards, your space. It may be one of those load and go. Put the rescuer in, clip them in, pull them out. Patient removal, patient decon. Again, a lot of this is going to be dictated by the space, the hazards in the space, and your patient condition. Key points of entry, limited access egress. We talked about earlier as one of the definitions of a confined space. And one thing to keep in mind as well, OSHA defines an entry as soon as any part of the body crosses the plane of the opening and that entrant is breathing the atmosphere of that permanent space. A lot of times it's very easy for an attendant or one of the riggers to become technically defined as an entrant. If he or she is helping out around that space and has to put their body into that opening to, say, manipulate somebody's harness that's hung up on the space's ladder area, or a common one where if you're wearing the escape bottle, sometimes that escape bottle may have to be manipulated to a degree so it doesn't get caught. So just be cautious if you're one of those attendants or riggers during this process. And technically, if you break that plane, if you're breathing that atmosphere, OSHA considers that as an entry. Sewer entries. Sewer entries are very unique in the fact that they actually have their own separate appendix part of the standard. There's three main aspects about a sewer that make it unique. One is a continuous system. And you can relate this for those of you that have trained with us in the hands-on drill in our waterways. That's a continuous system. Somebody could pull up on a side street with their car running and introduce a hazardous atmosphere into that space. Sewers the same way. It's a continuous system, and part two of that, the reason they're unique, is very difficult, if at all, a way to isolate the area. If it's a continuous system, it's also that gives the issue of the inability to not be able to isolate gases or other hazards coming into that space. The third reason they're unique is the fact that people that work in sewers, that's their job. So it's common for them to develop some form of complacency with that. So again, if you want to read it verbatim, it's about a page and a half worth of reading material, the Appendix E in the 146 standard. Confined space rescue equipment itself, here's a list generally taken right from the Rescue Association list. Supplied airline respirators. This is something we don't have to use all the time on confined spaces, but being a confined space provider, we have to have this available to us. It's simply a system where instead of wearing an air pack into the space, your air supply stays outside the space, and the rescuer wears an escape bottle. Ours are a 10-minute escape bottle, and they trail along with them an airline. The issue with this type of equipment is, one, you're bringing an entanglement hazard with you, and two, you're limited to 300 feet if you're using supplied airline respirator. Another thing to keep in mind as well is that escape bottle is simply for escape. So if something happens to that outside air, the rescuer can turn on that escape bottle, make their exit, get to a safe haven. But even if they fix the outside air issue, that rescuer has to come out of the space because they're required to have a full supply of escape air. Our supplied airline respirator system can be supplied either via the air cart itself with a 2-bottle system, or via the Cascade system on the rescue truck, which you see the second item there, the Cascade system. Patient packaging, patient removal, you'll see some examples of it through the presentation. Ropes, harnesses, hardware. Again, most of confined space rescue is rope rescue. Our atmospheric monitoring equipment is just our common air gas meters. One thing to mention about this, and this has been a common issue, I don't want to call it a mistake, but a common issue in the past, is when people go to use the air monitor to put the pump on, some have looked at the calibration cup that we commonly use every day for calibration, and they put it on the monitor to serve as the attachment point for the tubing. That is not sufficient. That's just a calibration cup. The monitor pump, we have a pump that's kept on Rescue 1 and a pump that's kept on Squad 2. The pump screws onto the face of the monitor, and it turns itself on when it detects that it's been attached to that monitor. So you have to use the pump in confined spaces. Ventilation equipment, we have a couple of duct fans we can use, lighting equipment, communications. The other, with our communications equipment, we actually have a hardline communications where the attendant is most likely the person that will have the headset on and monitor what's going on inside the space. The other issue with that communications equipment is you're also bringing an entanglement hazard. Typically, if we're using the communications equipment and the air system, the airline system, is we don't keep those two tied together all the time because you may need one, not the other, or vice versa. So if you are using both, sometimes we'll take electrical tape, and as it's going in, every several feet, tape them together just so they kind of match themselves together. Personal protective equipment, you'll see an example of it coming up. Lockout tag we've talked about. Everybody should be very familiar with our personnel accountability report tags. No different than our fireground scenes. We put your pass tags on, and we track everybody in team assignments and our various ICS forms. Alright, this picture here is just illustrating the operational technique we'll use ideally if a patient is in a narrow shaft, such as a person in a well. This picture was taken obviously from an area that rescue could have been lowered in, feet first and work, but for illustration purposes, this is what, say you had a kid in a well or a person in a well, you'd lower in your rescuer this way, because if you lowered them in feet first, obviously feet get to the patient, you can't bend over and do the work. So ideally, a person will be lowered down. They will either have a rescue line or a victim line with them and attach them in separately, and then the rescue will be raised up and the patient, or they can attach them right to their system and pull them up at the same time. Ventilation procedures. Continuous forced air ventilation shall be used and shall be from a clean source. A common mistake here, or a common issue here, is wind direction. You don't want your ventilation going into a hole, bad air coming out, the wind blowing it toward the ventilation system itself, the fan, and recirculating. Or you don't want to set your ventilation system up where it is, drawing in exhaust from either a generator, a vehicle, or whatnot. The generator has been an issue. We had an issue one day at our trench training where the portable generator was used to supply the power to our duct fan, and wind direction changed, and actually we noticed a spike of our CO with our air monitoring. So that's why our air monitoring is important as well. You can also use your ventilation for rescue or victim relief. Even if the air readings are good, you can still put ventilation in for that relief there. Some spaces actually have their own ventilation system. Example being, a lot of our lift stations will have their own mechanical ventilation system. We can use this system not solely by itself, but obviously if the system is part of the problem, it's probably not going to work. And we also need to make sure the victim is not part of the system as well. An example there's a ventilation system at the water treatment plant where it's like your traditional fan with a shroud around it. And obviously if the victim is part of that, we don't want to use it for obvious reasons. Here's just a ventilation illustration where you can put the duct tube right there by the patient's face, and it will blow the bad air away from the patient and provide a better chance of survival. The only thing to be aware of here is just your hypothermia. If it's real cold outside, just remember, you may have to worry about the hypothermia issue when you get your patient out. The most efficient way to ventilate a confined space is to introduce fresh air in the bottom, discharge it at the top. However, that's not always possible depending on your space you're dealing with. And obviously, never use oxygen to ventilate a confined space, not even a person in a well. And we discussed those reasons earlier with the flammability. Atmospheric monitoring. The entire space shall be monitored prior to entry. Sometimes this is not possible, especially if you have a space that goes down and then travels horizontally. In those cases, we just simply put a monitor on our rescuer, and they can monitor as they go. You see the order of testing there, that's straight from OSHA. Our monitors do them all at the same time. The biggest issue we need to be concerned with atmospheric monitoring is stratified atmospheres. Here's that 4-foot rule we talked about earlier. Ideally, on average height person, 4 foot hits around the chest area. So if you've got somebody standing in a bad air and a hydrogen sulfide, it's heavier in air, so they could likely be standing there in hydrogen sulfide environment, but not be directly breathing it in. But say they bend over and start doing patient care, now they could put themselves into that environment. So to alleviate this issue, we test in 4-foot increments. The rate of progress should be slow to accommodate the sampling speed of the detector. Our detectors, the sampling speed of it is about 1 second per foot. So if we've got our 10-foot hose attached to our pump of our monitor, we'll lower it in. First thing we'll do is monitor the opening area before we even pop the top, or start working around the area to make sure that the immediate area is okay. Then we'll lower the tube in 4 feet and we'll wait 10 seconds. Even though we're 4 feet down, it's still got 10 feet of tubing to go through. Wait 10 seconds, get your reading. Lower it down 4 more feet, wait 10 seconds, get your reading. and then lower it down the last little bit, and then get our final reading after 10 seconds. To help with this, we've actually marked our tubes, our 10-foot tubes, with black marks every 4 feet, so you don't have to guesstimate what 4 feet is. Also, use caution not to submerge the monitoring device into the space's product. One thing we can do to assist with this is actually tape a block, like a small piece of wood, on the end of the sampling probe, and that way if it does hit bottom, the piece of wood hits first and not that wand. There's a couple filters in the wand and all that hopefully will stop the travel of any product through the tubing to the monitor, but we don't want to take any chances with that and damage the monitor. Here's just an illustration, and the reason for, again, stratified atmospheres. If you just drop that monitor in midway, you could literally pass it right through a carbon monoxide or a methane environment and it not go off. And so it's just hanging, and say if it's hanging here, and like this third illustration here, you could have methane up top, hydrogen sulfide down low, and you're not detecting anything if you're just taking it from one reading here. So that's the importance of the stratified atmosphere. Before we talk about retrieval systems, another back to the sampling real quick. Another question I've been asked is, can't we just lower the monitor down into the space? Well, the problem with lowering the monitor down into the space, if this is a 40-foot deep space, and we lower this monitor down, and say 10 feet down, 10 or 20 feet down, our alarm goes off. Okay, or say we lower it down, and say it gets near the bottom and the alarm goes off. Well, as we pull it back up, we can't see what that monitor is, so we don't know what the alarm was, because we had to pull it back up and see what it is. And if you drop it down into bad air, so say we drop it down to the bottom of the space, it goes into alarm. By the time we pull it back up and it comes to good air, we may not see that reading. A lot of times the monitor will not reset itself. You have to manually acknowledge it, but you still won't be able to tell exactly what area that alarm went off in. So that's why we don't just lower the monitor. That's why we use our tube and our pump. I guess in worst case scenario, if say our pump went out of service or got clogged up, so we picked up some product in the sampling tube, the probe, and we just had no other resource, I guess it's better than nothing, but the absolute preference is to use our monitor. And most of the time you're going to have at least 2 monitors on the scene anyway, Rescue 1 being there, and Squad 2, you should have a couple monitors anyway at your mercy. Retrieval systems, this is another OSHA requirement that also has some exceptions to it. Anyone that enters a permit required confined space must be fitted with some sort of retrieval system. Also, this allows the attendant outside to retrieve them without making entry. This also requires the attendant outside to monitor the inside of the space. And the retrieval system itself must consist of a line attached to a harness or wristlets. Now, with that being said, if the retrieval system causes more of an issue, an entanglement issue, or let's say your rescuer goes down 10 feet and then travels 40 feet horizontally and has to go down another 10 depending on the space, that retrieval system, unless you set up some kind of pulley systems inside that space for changing directions or whatnot, that attendant's not going to be able to pull that entrant out. So there's some exceptions to that rule. However, if you choose to not wear the retrieval system at all times, it still needs to be available. You can't say, well, it's on the truck, it's available. It still needs to be hooked up and ready to deploy in a rapid manner. So here's your general PPE we discussed earlier. Your helmets, generally we're going to have a rescue style helmet versus the fire helmet. Our gloves, we will wear our rope gloves. Do not wear turnout glove or your turnout gear gloves or even your extrication gloves. Our harnesses have gloves that are assigned to them. Our rope and rigging bags have some gloves. So we want to make sure we're using our rope gloves so we don't cross-contaminate have any cross-contamination issues on our ropes and software. Our clothing typically is going to be what you see in the picture there, what you have on. Exception to that may be long sleeves. If we don't have long sleeves, we do have Tyvek suits on Rescue 1 we could put on. We also have some elbow pads and knee pads. Footwear definitely would be your safety boots, your safety shoes, your eyewear if you're not wearing the mask for supplied airline respirator or SCBA, safety glasses, and then your respiratory protection. This picture here is denoting this is the escape bottle on the rescuer. The yellow bottle here is your 10-minute escape bottle, and you can't see it real well, but the little nipple here is where the airline comes from the air cart and hooks into the rescuer. One thing, if you notice, and this is one of those things too, if you haven't familiarize yourself with it, these escape bottles, is we're used to putting our air pack on and over our left shoulder is where our regulator comes off of. That's what we preach in Firefighter 1 and 2 and Rescue and Firefighter Survival, RIT and Mayday. Our left side is our life. Well, with these supplied airline respirator systems, it's actually not. The respirator, the actual regulator, comes off the right shoulder, as you see here. But what is off the left hip? The escape bottle. So that rule still applies. It's just a different device, where our SCBA, that regulator comes off our left shoulder. In supplied airline respirators, the air bottle itself is on our left hip. So you can still maintain that left for life. That left side is what you will need to concentrate on to protect your respiratory protection. Your medical considerations, again, we briefly talked about earlier, your patient packaging. Spinal mobilization needs to be considered. Again, for getting them out of these spaces, we may have to use a backboard. Generally, we're probably going to use the sked stretcher for that, just because it's conducive to confined spaces. Stay and play versus load and go. If it's just an injured person, example being Indianapolis recently had, as I mentioned before, the water tower rescue. The person fell, broke his leg. The atmosphere was fine. They wanted to make sure the patient didn't get further injured, so they took some time and packaged them correctly, and mobilize the injuries and extricate them in that fashion. If that had been an atmospheric hazard issue, more than likely they just would have loaded and go. Hook them up, get them out, and we'll worry about the injuries when we get them to a safe environment. The other patient packaging devices that can be included or listed here: your KED, your spine splint, your sked, your halfback, and your Stokes basket. So this is the sked device. Most of everybody's familiar with this. Again, just one of those things that's pretty easy to get off the truck and play with a little bit. Ours is fairly new, our new one. It has the Cobra buckle, so it's a little easier to snap in place versus having to weave a strap through a buckle. The issue with the sked, as you see in the picture on the left, it provides no spinal mobilization at all, where we can use the spine splint or even a backboard. If we do have some spinal issues, we can put them in this to protect that spine area. The other issue with the sked device is how it comes packaged. It comes packaged rolled up with a keeper strap in a bag. If you're going to deploy this, a team outside the space needs to go ahead and get it out of the bag, unroll it, get it set up, and send it in preset. And typically preset is it's unrolled, and there's 4 straps that go across the body, and there's 2 foot straps. Ideally, we'll take those 4 straps across the body, go ahead and hook them up and kind of take some of the slack out of it so it pulls the sides up of the sked device. We can leave the foot open, but that's ideally how we want to deploy it to send it into the space. We definitely don't want to just pass the bag down to them, because you can imagine trying to unroll this sked device inside of a confined space. It's a little, it's not conducive for that. Here's the organ spine splint that is used in conjunction with the sked. It's pretty much the rescue version of the KED. It pretty much serves as like a short backboard with some straps that go across the upper body and crisscross over the shoulders. It mobilizes the C-spine, the head. Again, as you see in the picture here, it can be used along with the sked device. Other considerations, a harness clip-in. Let's say you've got that worker that's fallen into space. As long as they're wearing a harness, you can do this. The rescuer goes down, clips into their harness, and brings them out. Prior to this, we want to make sure their harness is good to go. Obviously, if they fail because their harness failed, we don't want to hook them into that. Placing a patient in a harness or a hasty harness, a rescue knot. A general rule or a general process is for a rescuer, if they're unsure of what the patient has on or doesn't have on, if they take a webbing sling with them, or in our case now, the cinch collar, they can actually use that as a hasty harness to wrap around a patient and pull them out. The wristlets is another version of rescue device. As you see in this picture here, it simply goes around the patient's wrists and attaches to the mechanical advantage system that pulls them out. The concept behind this is, as you can see, even for narrow spaces, it brings the profile of the person, it narrows it up and allows easier removal. If the patient is conscious and alert, you can instruct them to, in addition to them wristlets being around their wrist, if they hold on to those wristlets with their hands, it'll take some of that pressure off of the wrist. But the good thing about them is the more they pull, the tighter those wristlets get. The sked, we talked about in inverted, we saw the picture of that. And Stokes basket, it's available, however it's not the primary use because of its rigidity, and it's kind of hard to manipulate in and out of a space. And here, this is a guideline on a confined space rescue setup. All this does really is it's a good guide for the fact of the operational aspects. If you look at the tripod here, using the 3 legs, you kind of got everything coming in one leg section here. You've got your air supply line, your communication lines, your attendant can stand here. So any of your rigging and all can kind of come in this area. Then in this area you got your ventilation fan. So this section here is for your duct tube. And in the last area here is where your riggers can stand. This also serves as a good open area, so when you get the patient out, you can bring them out to an area and you don't have to worry about stepping over a duct fan or stepping over communication lines or whatnot. One thing to use caution of, though, especially if you're using a tripod, is when you're bringing that patient out or that rescuer out, if you start pulling on this tripod outside the footprint of that tripod, you can have some issues. It can turn over. So make sure before you pull that patient down that somebody has disengaged the locking mechanism of that mechanical advantage system or that lowering system, and also do it slowly, because even if you disengage that device, if you bring them down too fast and they get outside that footprint of that tripod, it can cause some issues. And then the last phase is the termination phase, phase 4, personnel accountabilities. As you saw before, even during this, and probably more so during the termination phase, because by this point we're all tired. It's been, everybody's done work, physically, mentally. So account for everybody, even if it means taking a break, rehabbing, and then bringing everybody back in for the breakdown. Equipment retrieval, collection versus abandon. Sometimes if a piece of equipment is left in the space, and obviously depending on what kind of space it is, there may have to be a decision on abandoning it versus sending a person in to get a piece of equipment. Obviously we ultimately want to bring everything home with us, but again, if it's one of those risk-benefit analysis concepts where we can leave it in the space and in lieu of setting everything up and risking somebody's life over a piece of equipment, that's going to be a decision that's going to be made by the incident commander. Decon, as we mentioned before, is also involve hazard materials. So whether it's a hazmat team that comes in and helps us with decon, or whether we do a mass decon setup, it really again depends on the contents and the overall operational aspects. The investigation process, or the investigatory process that likely OSHA will do, or the site area will be a part of. Release of control, like any other scene. When we get done with our job, we will release the control back over to the owner. And when we do this, we definitely need to make sure everything's relayed to them. If we've locked out and tagged out certain devices, it's things we've shut down power to, or if we've had to damage equipment to get the patient out. If we've had to take a piece of equipment apart or manipulate some equipment to get the patient out, that information obviously needs to be relayed to the appropriate personnel. And then the critical incident stress debriefing needs to be considered as well. All right, so that wraps up the operational concepts. As far as confined space rescue team requirements, facilities do have the option of using an in-house team or an outside response team. And for the outside response team, we do provide that response to various entities in our district. To be a confined space team, whether it's in-house or an outside, you have to train at least once every 12 months with the rescue team, with the ones that are classified as entrants or technicians. They must make an entry into a permitted space or simulated permitted space and actually rescue a mannequin, a dummy, or an actual person. Just by popping the top of a manhole, lowering somebody down, and then raising them up, that does not constitute as satisfactory confined space rescue training. It can still be used as training, but it doesn't meet the requirement on qualifying or recertifying, for lack of better terms, that person to be an entrant, a rescuer. Also, each member of the rescue team must be trained in first aid and CPR, which we have that covered through our regular training. Here's the Appendix F. I believe I mentioned earlier, as far as like the notification process. If they notify us, if a facility notifies us that they're doing confined space entry and we're doing training, or when we do training, we notify the ones we serve as well, because the Appendix F, this provides employers criteria to use to evaluate a confined space rescue team. OSHA doesn't say they're mandatory. It's not a mandatory requirement that they evaluate the team, but it does put it out there in the standard as a, hey, look, if you're going to rely on this team, you may also want to make sure they can do what they say they can do. And again, as I mentioned before, Selma Fire Department, we actually provide some service to them, and we've actually done some live training with them at one of their facilities, as you see denoted in these pictures. All right, well, that summarizes everything. To kind of break it all down, again, remember, confined space rescues are considered a high-risk, low-frequency. Number one cause of fatalities in confined space is atmospheric, often invisible and odorless. It's imperative to know the limitations and processes for executing a confined space rescue. We've discussed a lot of them in this presentation. By no means is it a very in-depth on every single operational concept, because it really takes some hands-on training to really get the true grasp on some of the operational aspects. And also, you need to stay up to date with the training and standards. And again, this is one of the reasons we're doing our distance learning in this manner. And just as a reminder for the test completion, if you're doing this as far as your annual requirement for awareness, just simply go on the Fire Manager, go to the Forms tab, select Confined Space Rescue Awareness Test, submit it, obviously complete it, submit it. I'll be notified. I'll send back any issues and resubmit it. And then just another reminder, have the on-duty shift personnel. They can do the training entry for Confined Space Rescue Awareness, and it's in Firehouse Rescue Training for Town of Clayton, CFD Confined Space Awareness. And if there are any issues with the test tab or the training entry, by all means, just feel free to give me a call. Just give me a contact. Call my office or send me an email, and I can walk you through those. Thank you for joining us for this session. And again, if you have any questions or need clarifications on anything, you can get a hold of me, and we'll see you on the big one.